Hey there, students. Today we're making a video and we're taking notes about solving some simple exponential equations. Okay, so pretty simple stuff going on here. I hope you think it's simple, and if not, well then I'm going to try and make it as simple for you as we possibly can. So there are two different ways to solve exponential equations. One is by trying to make the bases of both sides the same. And what I mean by that is on the left side here, I have a base of 2. And then the right side is the number 16. Okay, so if I could somehow write 16 as 2 to some power, then I can apply a property. And that property is because exponentials are 1-to-1 functions, which means every 1y value comes from every 1x. So if my bases are the same, okay, so if this is 2 to the, what happened? Whatever happened there, I don't even know. If this is 2 to the 2x minus 4 power, and this has a base also, then by that property of it being 1-to-1, these exponents must be equal. Okay, because if the left side is actually truly equal to the right side, then everything about those things must be the same. Okay, so it's a pretty handy property. So we need to think to ourselves, okay, self, how many 2's do I need to multiply together to get to 16? And the answer is 4. If I do 2 times 2 times 2 times 2, that gets me 16. So now I can apply the property that because my bases are the same, the exponents must be equal. Okay? So now I just have a simple algebraic equation to solve. 2x minus 2x equals 8, so x has to be 4. My exponent had to start out as a 4 in order for the left side to make the right side true. Okay, so this is one of our strategies, is by making the bases the same, then the exponents must be the same also. So let's see about this one, 32 and 16. Can I make those bases the same? Well, a second ago, I knew that 16 was 2 to the 4th power, okay, and I still have this x plus 4 already there. So this turns into a multiplication problem. Now, how many 2's multiply together to give me 32? Okay, that is my new question. So 2 times 2 is, of course, 4, times 2 is 8, times another 2 is 16, times another 2 is 32. So if I multiply 5 2's together, that gets me 32. And I still have my x exponent there also. So now that my bases are the same, I can set my exponents equal to each other in order to solve this equation for x. Okay, because that's where my variable is. My variable is in the exponent, so I need to find a way to bring my variable out of the exponent. If I can make my bases the same, then the x's have to be equal, and we can solve this for x and get x has to be 16. If I raise 32 to the 16th power, and then I had 16 to the 20th power, those two numbers would be equal. Okay, it was pretty large numbers, in fact, but nonetheless, that's what would be. Okay, so one methodology, one strategy to use when we're trying to solve an exponential equation is to make the bases of both sides the same. Now, that can't always happen, so we have to have another strategy. Okay, and that strategy is, what do I do to an exponent or an exponential in order for the base to disappear, right? Quote unquote disappear, air quotes. It doesn't really disappear, but right, they inverse out, they undo each other. And that answer is to take the log of both sides. Okay, a log and an exponential are inverse operations. So if I have an inverse equation, if I want to get rid of that, then I need to take the log of both sides. Okay, so the other way, and this works on the others also. Every single time you could take the log of both sides and it will always solve an equation. And you can take whatever log you want to, okay? But if you want the 2 to actually quote unquote disappear, this 2 right here, right, your base 2, then we want to take log base 2. Okay, because the property says when the bases are the same, the exponent is your answer, right? They undo each other. So we log both sides. Log base 2 of 2 is 1. Okay, because 2 to the first power equals 2. So the answer to a log question is always an exponent. And we allow the property that says you take the power from your exponential and bring it to the front. So this turns into x plus 3 times log base 2 of 2. And like I just said, log base 2 of 2 is the number 1. So x plus 3 times 1 is just x plus 3. And on the right side, we have log base 2 of 10. Right? Now, if you're so concerned, this number is a decimal. Right? All logarithms are basically decimals if they're not perfect logs, I say perfect. Okay, this is just a decimal number, and you have lots of calculators and different ways to figure out what that is as a decimal. Okay, so we are just doing math with decimals. That's all a logarithm is a decimal. So when I subtract 3 from both sides to finally solve this for x, I have whatever log base 2 of 10 is as a decimal minus 3. Okay, now that's the perfect answer. If you wanted to use a calculator, okay, and get a decimal approximation, I will tell you that the log base 2 of 10 is 3.32193 when you round to 5 decimal places. And minusing 3, we would have a power or an x of 0.32193. Okay, so if your teacher wants you to decimalize things and use your calculator, then you better find a calculator that you know how to use. Okay, Apple iPhone calculators are sometimes really tricky depending on what update you have, right? Androids, there are lots of apps for Androids that will do that for you. There are lots of other apps that will do it also. So find a way, if your teacher wants a decimal, to find out how to decimalize that, right? Do your best. You can probably do a search, an internet search, and it will give you lots of ways. But I want to talk about the math. Okay, so here we have another exponential. In this case, we have a base of e, right? Base e. So base e is a special natural number, so we're not going to take the log, right? We could write log base e. But log base e, we don't write log base e, right? This is better known as the natural log, the ln, the natural log, the logarithm natural of e to the 1/2 x minus 4 equals the natural log of 6, right? Whatever log you take of the left, you have to take of the right. Now, we use that property that says when you take the log, the exponent becomes your product, right? It comes to the front. So you can move your 1/2 x minus 4 to the front, and we're going to multiply that by the natural log of e. Well, hopefully you recognize from the last problem, the natural log of e is 1, right? That's why we take the natural log, so that the bases are the same, and the answer is just 1. So we just get the 1/2 x minus 4, right? We get the exponent. And on the right side, we have natural log of 6. Now, once again, you can decimalize natural log of 6, right? This is a decimal. Your calculator can take this and approximate it with a decimal. So if that's what your teacher wants, now would be a good time to do that. But we're going to solve by adding 4 to both sides. So 1/2 of x equals the natural log of 6 plus 4. Remember, this is a decimal. The 6 and the 4 do not combine together. Okay, natural log of 6 plus 4. And then our last step would be to multiply both sides by 2, because 2 times 1/2 is 1. So we would multiply everything by 2. So there's lots of ways to write this. We could distribute, right, and get 2 natural logs of 6 plus 8, right, which is fine. We could, right, if we're crazy enough, take the 2 from the front and move it as the power, right, of your 6. That's also acceptable. I don't know if your teacher wants you to do that or not. So then ln of 36 plus 8. Either way you slice it, no matter which method you pick, right, is you want to see it as a decimal, 2 times the natural log of 6 plus 8. These all should give you a decimal of 11.5835. Okay? No matter what, this one gives you a decimal, this one gives you that same decimal. All of these give you that same decimal, right? Because mathematically speaking, they're all equal. So all the answers are going to be the same. Okay, so the math. The math says when you're solving an exponential equations, there are 2 ways. One way is if you can make the bases of both sides the same. If the bases of both sides are the same, then the exponents must be equal, and you can solve a nice algebraic equation with your exponents. And if you can't make the bases the same, then you can always take the log of both sides. You take the log with the same base as your exponent so that that becomes a 1 and is essentially eliminated from your equation. Okay, there you go. Some simple solving of some exponential equations. Hopefully this helps and your brain is ready to go. All right, goodbye.